Hello everyone. So the last problem for the day is minimum subset sum partition problem. So what does the problem say? The problem says that given an array, you were supposed to divide the array into subsets S1 and S2 such that the absolute difference between S1 and S2 is minimum. So let's say we are given with this one 1, 6, 5, 11. We are supposed to divide the elements into two subsets, right? Such that their absolute difference is minimum. So let's say we have 11 in this one and the next bigger item is 6, so 6 should go in this one. We need to minimize the difference. Then let's say we add 5 over here, and since 11 is quite large, this will be 11, so the other one we can add anywhere, like +1 or +1 doesn't really matter, both of them are 11. So what will be the minimum difference? The minimum difference will be 1. For this case, let's say 36 plus 40 minus 7 plus 46. So the minimum difference between the two subsets is 23. So that is our main task over here, to find the minimum difference between two subsets, right? So like by reading the question, there is something that should strike you, that is like you are dividing an array into two subsets, right? So something which is very intuitive is the central tendency. Like if you try to think a little hard, you'll realize that this is a problem where we are tending towards a central tendency. So the more central, the more equally distributed both of them are, the better the solution, like lesser the difference, we get the minimum value. So where did we do such a problem which was pretty close to that? Let us think of the problem where we divided, where we were supposed to find the minimum, no, where we were supposed to find whether there is an equal partition in a subarray, right? In an array. So what did that problem say? According to that problem, if there existed a subset whose sum is equals to half of the total sum of the complete array, we get we can divide the array into two equal halves, right? So what is the minimum difference in that case? The minimum difference is 0. So that is the best possible situation. So from this we get an idea that the sum of each subset should be closest to half of the sum of all the array elements. Like let's say this will give us a sum of 22, I guess, sorry, 23. So we need to find the each of the subsets should be closest to 11.5, and one is 11, one is 11 plus 1, 12. So the difference we are getting is 1. Okay. So yeah, if we think, like I was saying, if we think about the equal sum partition problem, what we did there was we found out a subset with sum equals to total array sum by 2. In that case, whenever there was such a subset, the minimum sum partition difference was 0, right? So let us try to think in terms of the subset sum problem and equal partition problem, right? So let's say we create this kind of a matrix where this is the sum, where sum is the sum of all the array elements, and this is 0 to n. And let's see what does this last row mean. The last row in the complete array, what does this mean? So if this is 1, this means, let's say, let me draw it over here properly. So this is, let's say j, this is j minus 1, this is 0, this is 1, whatever, and this is n. Okay. So if we get a 0 over here, this means there cannot be, if we consider the whole array, if we go through the whole array, there cannot be a subset whose value adds up to j. What does 1 mean? 1 means if we add up, if we consider all the array elements, there is a subset whose value add up to j minus 1. So to find the minimum difference, so to find the minimum difference, let's say there is something called sum by 2. Okay, so let's say the sum of one particular subarray is S1, sum of another particular subarray is S2, and that is equals to sum. Okay, now the minimum difference between both of these elements will be when S2 will be closest to S1, right? So when S1 is equals to S2 is equals to sum by 2, so that will be the best possible situation. So what we do is we create this we create this matrix till sum by 2. Okay, and if we get a 1 over here, what this means is essentially that there can be a subset with sum is equal to sum by 2. That means the minimum difference is 0. If we get if we get 0 over here and 1 over here, this means there can be a subarray with sum is equals to sum by 2 minus 1. So the minimum difference is greater than this. Like, let's see what will be the exact minimum difference. Okay, so yeah, S1 plus S2 is equals to sum, and S2 is equals to sum minus S1. We already know that. So the minimum difference will be sum minus 2 into S1. Like, you get this, right? So we have S1 plus S2 is equals to sum. So the minimum difference between S2 minus S1 will be sum minus 2S1. So since we now understand that the minimum difference is equals to sum minus 2S1, we will solve the same problem. Like, we will solve this problem as the subset sum problem only, and we will only check the last element. We will only check the last row starting from the right end. So what does this mean is, and we will stop when we find 1. What does this mean is, so if we get a 1 over here, this means there can be a subset with sum is equals to sum by 2. So what will be the difference then? The difference will be, minimum difference will be sum minus S1 minus the other element. What is the other element? The other element S2 is equals to sum minus S1. Yeah, so sorry, sum minus the other element is sum by 2. What will be the other element? That will be sum minus sum by 2. So that gives us 0. So yeah, and if we get 1 over here, this means minimum difference is sum minus minus 2S1. What is 2S1? 2 into S1. What is S1? Sum by 2 minus 1. So is equals to 2. So if we get 0 over here, we get 1 over here, what will be the minimum difference? Minimum difference will be, once again, 2 into minus 2. That will be 4. So this will keep on going. So the minimum difference between both the elements will be, like, we will only stop, like, we will start over here from over here. So as you can see, the we get a minimum difference of 0 over here, minimum difference of 2 over here, minimum difference of 4 over here. So we keep getting a minimum the minimum difference keep on increasing as we move this side. So we will only stop when we get a 1 over here. The first one will be the minimum difference, will denote the minimum difference. So let's take a look at the code. For I is equals to 0, I less than n, sum is equal to sum plus plus. We are creating the sum, we are storing the half, we are creating the dp, half plus 1. This is the base cases, and then same as the subset sum problem, like we did. And now this is the new thing. What we did is, we started with I is equals to half, and we moved away I minus minus from half to 0, and dpn. So we are considering the last, n 0 0 sum by 2. We are considering the last row, and we are whenever we get the first one, we are considering a break, and we are calculating the minimum difference, and we are returning the minimum difference. I hope it was clear. Thank you.